Great. Oh, fantastic. I was being a jerk to myself. No, I think I'll be fine. But like, I don't know if you guys have ever taught a class, but sometimes like, you're writing like rough notes of what you're going to talk about, and you get something like, oh yeah, I'll be able to figure that out on the spot, and so you leave it out. So like, whenever I wrote these notes, I decided that I could prove this off the top of my head, so I didn't include a proof. So let's see how I do. That's more of a disclaimer than it is actually a story. But okay. So we want to show if x is greater than 0, then minus x is less than 0. And I erased what it means to be a field, but I think we're going to be okay. So, so what's the point? We have x is greater than 0. So, oh, and I should actually put this just, and vice versa. I mean, if you get the other result, right? If x is less than 0, minus x is greater than 0. Fine. So how do you guys think we're going to prove that minus x is less than 0? Yeah?
Add the additive inverse to both sides.
Perfect. What if we add, and actually I'm going to start doing it right now so we get used to it. Adding the additive inverse is the same as writing this. Right? Or 0 minus x if you want to be really tough. Well, we know since we added the same thing to both sides, the inequality doesn't change. That was the first assumption of being an ordered field. So this inequality doesn't change, so we get 0 is bigger than minus x. Yeah? So maybe I should put letter A here, to be precise. And that's it. Minus x is negative in this case. And I'm sure you guys can see how to do the other case, like the x is less than 0 case. So now we let x be greater than 0, y less than z. So I want to prove that xy is less than xz. I wish I hadn't erased it. Well, I also don't have any board space. But if you look at the second thing in there, the only information, so if you look at your definition of ordered field that you all are staring at, hopefully, the second thing only gives us information about multiplying positive numbers, right? So I can't just go ahead and multiply both sides by x because we don't know what that's going to do. The only thing I know about is multiplying positive numbers. How can I make this an expression about positive numbers? Subtract y from both sides, right? Or add negative y to both sides. If I add negative y to both sides, this is the same as saying z minus y is positive. Yeah? We agree? Which means, well, what can I do now? Well, I now can multiply by x. If I multiply by x, I know the product of two positive numbers is positive. Again, the second assumption of an ordered field. So then I get 0 is less than x times z minus y. Or otherwise, 0 is less than xz minus xy. So if you wanted to be, this is like number 2 for ordered fields. I messed up, I should use letters. And this thing here, what you want to call distributive law. And then we move everything over again just by adding additive inverses. And we get this. This is number 1 for ordered fields, so on and so forth. Yep. I hope no one's surprised. Yeah, everything's so nice so far. All right, so let's talk about proving letter C. I'm going to put the proof here because it's very short. What do I do to prove that if x is negative, y is less than z?
Just B, but you use A.
What?
Oh, it's just like the proof for B, but you use A.
Yeah, I mean, I was thinking of that. I don't think that is actually going to, well, yeah, that will work. Yeah, that's a good way. So one way we could do it is just combine the facts. So we could just do this trick again, right? The only difference is now y is greater, or you're assuming maybe y is greater than z. So you just subtract over to the right side and then multiply. But I don't think that's going to be nice here. So instead, I'm just going to, I'm going to use your trick. So we already know, so we know since x is negative, y is less than z. Sorry, I really hate that sound. We know minus x is positive. Right? So otherwise, minus x, y is less than minus x, z. Or I'm going to ditch the, you know what, screw it. I'm ditching the parentheses. I heard yesterday I could. So the problem is right now you might see is that I can't just take negative of both sides because we're trying to prove that that makes sense. So what I would do now is maybe shift everybody over to the one side. So this is what? xy minus xz. And then shift this guy back over here. xz minus xy. Yeah? That's the same thing. Cool, so we have the first three things. They weren't too bad. This one's the only one that's fun, and I don't quite remember it. Oh no, I do remember how to do this. This is very easy. Okay, cool. So now we should prove D. Oh, that's not too bad. So, so the proof of D. Well, okay. So how should I prove D? What's that? Right. So we should start with trichotomy, right? Because we know x is not 0, so x is either bigger than 0 or less than 0. But the reason I was asking how I should prove it is this is the first time I'm going to do something called breaking it up into cases. I'm going to deal with the case where x is positive, and I'm going to deal with the case where x is negative separately. So, and again, I know, I'm sorry if this is a little slow for all you guys. I promise you next week you're going to be wishing I still was doing this. That's not sort of a threat, that's more of a, things will be tougher. But, so if x is greater than 0, well, what do we get? Well, we know the product of two positive numbers is positive. That's number 2 from our definition. So x squared is greater than 0. Yep. Cool. That was nice and easy. What about case 2? Now we're assuming x is less than 0. What should I do? What? Perfect. Minus x is bigger than 0. And so that means minus x squared is bigger than 0. So I've been told it has to do with the resonant frequency of this, like the length of the chalk, and if you like break it in half, it doesn't do that anymore. But I don't think that works. Well, we can try. I don't know if you guys know that the squeaky sound, like there's a resonant frequency based on the length of your chalk, and it actually is playing like the first 2 or 3 fundamental frequencies are the ones we hear. Oh, whatever. Maybe I'll teach you some of that later. So anyways, this we already know is equal to x squared, so we're done. Right, because we just take one minus, this is minus x times minus x, you take one minus out, you take the other minus out, and we know minus of minus is positive, right? We proved all those properties yesterday, so great, we're done. And then what do I have left? I want to prove E. All right, this one's actually kind of cool. Kind of. So now we have x is less than y, and they're both positive, and I want to show that last inequality. So what do I have to show? I think that's where it's a good place to start. So I have to show that 1 over y is less than 1 over x. But is that the only thing I have to show?
So 1 over y is positive.
You want to show 1 over y is positive. You also want to show technically 1 over x is positive, and you'll see why for the final proof. So let's start by showing that 1 over each of those is positive. Okay? Anybody see how? Yeah.
You multiply y with 1 over y, you get positive.
1 over y times y is equal to 1, which we know by part, whatever the hell, I guess the consequence of d, this is positive. Right, so can 1 over y be negative? No, because y is positive, and we already proved if y was negative, it would switch the inequality. That would be part B, C. Yeah, does that make sense? So 1 over y must be positive because, and I know, this is, well, because of that, whatever. I know I'm doing a pretty sloppy job with these proofs because I just don't need to put all the words in right now. I think you guys are getting it. But like if I was writing this up for homework and I thought I had a really anal grader, I actually don't know if our grader's anal yet. But if I thought I had a really anal grader, a lot of the stuff I'm saying would be written in words along with my proof. At least justifying what I'm doing. But 1 over y is positive. And so similarly, see, this is 1 over x is positive. So what does that tell us? 1 over y times 1 over x is positive. Yep. So what am I going to do? I'm going to multiply this inequality right here, or oops, this inequality right here by 1 over y times 1 over